So in the previous KiCad video, we learned how to create a custom symbol, and here in part 9, we're going to learn how to do more advanced custom parts, and by that I mean components that have multiple units, DeMorgan representation, alternative pin layouts, and we're going to see how to make power symbols. Now, before I get into it, you'll probably recognize that it's been about 6 months since part 8. I'm saving the full details for the January update video, but long story short, I've decided to stop making videos like this that are in the sort of tutorial/workshop format. 2023 was a terrible year for this blog, so I don't really think there's much of a future in the style of video I've been doing. So partially because of that, this video is unscripted, and you're probably going to hear some of the background noises I would normally edit out of it. I've been busy doing other projects besides this blog. I'm going to be blunt and say that I don't think a lot of this is worth the effort anymore. As a side note, if you like the KiCad project like I do, it is their Drive week, or I guess Drive month, going on right now, so if you're on the website, just be sure to give it a look. So what I'm going to do is create a brand new project. I'm going to find a directory on my system to put that project, and this project is going to be the one where we store not only the schematic, but all the custom parts. So I believe we're going to make 5 in total today. So now that we're back at the home page, we could go into the symbol editor and edit the symbol that way. But just to make it a little bit easier for people, I'm going to open up the schematic. The schematic is going to be the place where we place the custom parts after we've created them. So now we've got the blank canvas. If you go up here to the top, you'll see the symbol editor, and that's where we're going to do most of the work today. So this window that just popped up that I'm reducing in size so that you can see both the canvas and the editor, this is the custom symbol editor. You can also edit existing symbols in it. And so what we're going to do first is go up to the top left corner and create a new library. Now, a lot like that previous video, we're just going to make this a local library that won't affect things globally. So what we're creating today is not going to affect, for example, the next project that we make. So now that I've created this brand new custom library that is named New Library, you're going to see on the left that there's a very long list of existing libraries that came with KiCad unless you elected to not install them. So to make our custom work a little bit easier to find, what I'm going to do is on that left-sided list, you can right-click your library and you can pin it to the top of the list, and this will make it a little bit easier to find. So let's go ahead and click the new symbol button, and this is going to be where we create that new custom symbol. Go ahead and copy the symbol name as I put it here, so I'm just naming it foo, which is a placeholder name essentially. And click OK, and you can see that we have the default reference designator that we picked of the letter U. First thing I usually do is move that out of the way because it doesn't need to be on the origin, but the main thing you want to do first off before you do any work is check your grid, make sure it is 50 mils, and as a reminder, 1 mil is 1/1000th of an inch. And optionally, you can adjust the cursor to have larger crosshairs, but that's not really required here unless the part gets really big. So like I said, the first thing I usually do is move the ref des out of the way. You now have a choice of Unit A, Unit B, and Unit C. So this is going to be the style of symbol where you can have the symbol basically broken up into different parts and place those parts in different locations on the screen. First thing I'm going to do is make a couple of pins. Because this is a example, the pin names don't really matter too much, but the main thing you want to do is not accidentally reuse the same pin name because that could trigger error detection later in your project. I'm going to make an input and an output. I'm numbering them correspondingly and naming them correspondingly. And then on the right side, we can go ahead and take some of those custom shapes and just give it any type of rectangular shape for now. So next, up at the top, I've selected Unit B, and this is going to be our second unit, and you can see that once you change the unit, the screen changes, it essentially goes blank, but you keep the original reference designator, so you don't need to copy that every single time. I'm going to go ahead and create some new pins here, so these will be address pins 0 through 2. By the way, this video is a little bit different from my usual ones, so normally I would record this, I would script the audio, record the audio, and then as I'm listening to the audio, actually do the work inside this application. Because I'm kind of short on time, I'm just commenting on work I've already done, work I've already recorded on the screen. So that's why the pacing is a little bit different today. And then once again at the top, I'm going up to Unit C and just creating 2 power pins. Traditionally, your 2 power pins, or if there's even more power pins than that, those will be a separate unit. So for example, in the Pine64 PinePhone, if you look at the schematic that they put on their website, and you can get the schematic for it, that processor, which has, I believe, something like 300 or 400 pins on it, it's broken out into multiple units, and the power pins essentially are their own unit. Usually that happens because you want to have all of your voltage rails visible in the same area of the screen or same area of the page, just for easy reference. So now up at the top, I'm using the pin editor table, and this is a pretty useful tool for just double checking your work and making sure that you've named everything correctly, you haven't duplicated any pin numbers. So for example here, I had the address pins that I meant to be input pins, and they were flagged as outputs, so I'm fixing that here. There's a couple other things this table can do, but we'll get into that later. You can also click this other icon up at the top and it'll do a quick check. The main thing you don't want to do in this editor is put your pins off grid, because that can really just wreck your ability to wire things up later. So finally, I'm taking the custom symbols properties, and you can see it's opened up a dialog window here. This is where you can enter your part description, your keywords. You can check and uncheck things. So like in the bottom right corner, it says things like exclude from bill of material. So for example, your power pins, those are never going to be in the bill of material, because that's not really a component. It's more like a net within the project. Now finally, there is the what's called KLC, KiCad Library Convention. And the convention is if the function of your device isn't obvious from looking at the shape, what you traditionally do is you right-click it and you set the fill color to the background color. So if you're following the default color scheme, that's going to be yellow. And if you're using one of those custom themes that I showed in, I believe it was part 0 or 1, it's just going to be some other color. Okay, and we have units 1, 2, and 3, or A, B, and C, depending on how you like it. There is an option to use numbered units instead of lettered units. I'll also show that one at the end of the video. And to make sure that everything we've just done takes effect, first of all, save your custom part inside the editor, and up at the top there, you can click the refresh button, and this will refresh the add symbol dialog to include your new work. Now, something strange happened with KiCad 7 here. I believe this was version 7.0.8. It crashed when I was trying to load the list of symbols, and I actually had to kill the process, so I went into Task Manager, closed out KiCad, and reopened it. I don't know if that's a bug or something, but it does seem like it's done that at least 2 or 3 times in the past. But I guess it is worth mentioning that by default, KiCad will autosave you. I believe the default interval is every 10 minutes. This one did not save the schematic, so yeah, getting a weird error message there that probably didn't make a lot of sense for the situation. But now I'm back in the application, and you can see that everything in that custom library is saved, and the list of components is loading at a pretty decent pace now. So once again, I'm looking for that new custom library, and if you click the arrow next to your library name or your part name, you can now see those subunits broken out by default. It's going to be by letter, and the default libraries that you get with KiCad also have a lot of units with subunits. They also have units with DeMorgan, which we'll see next. And if you click the checkbox at the bottom of that dialog, it makes it a little bit easier to add the units A, B, and C in sequence. That's pretty useful because if you're using somebody else's custom part, you're not necessarily going to know how many units there are, and it would be easy to accidentally miss one. And from here, everything else just works kind of like you would expect it to, just with a normal component that you've added via KiCad. So at this point, let's add that second component. So what I'm going to do is first highlight the name of this custom library. That will instruct KiCad that you would like to add to that library in particular. There used to be a different mechanism for that one, but it was, I think, pretty confusing. And let's create a new part. This part is going to be a DeMorgan part. So in the initial dialog, make sure that you have checked DeMorgan in the checkbox, and that should be the only one that you need to check. So once again, I'm going to place a couple of pins. It doesn't really matter what they're named or numbered, just don't duplicate the numbers. And for now, let's pretend that this is some type of like really fancy Boolean logic gate. So two inputs, two outputs, or one output rather. And we're setting the background color, kind of moving the text around a little bit. And up at the top here, this is why it's called DeMorgan. So in Boolean algebra, there's a, maybe to back up, if you're designing combinational logic, like maybe for an FPGA, and you're trying to figure out your circuit in Boolean algebra, you have this property of DeMorgan's law, and especially when you're making decoders, it can simplify your logic and give you an opportunity to reduce the number of gates. If you show yourself a DeMorgan representation, it's kind of hard to describe it in one short video, but the point is these two icons at the top here actually represent a identical logic function, even though one of them has inverters at the input and the other one has an inverter at the output. Both of those representations, both symbols, mean the same thing. So that's the original meaning of DeMorgan. I suspect that a lot of people don't really use that anymore because unless you're working with FPGAs, combinational logic is probably not something you're going to get into a lot. But anyway, the feature is there, and you can kind of see that it works almost like a multi-unit system where there's just two units. So you have your default representation, and then you have this sort of alternative DeMorgan layout. So in my case, because it's just a quick example, I'm making one a rectangle and one a circle. One thing that is somewhat useful to do when you're doing this is just make sure that the pins are in the same location, and that way, once you get into the schematic, if you decide to switch from one system or one representation to the other, your pins aren't moving around and they aren't causing wires to become unwired, which I'll show later. Okay, and from there we can see that it works pretty much as planned. Once again, we're bringing up the pin table, and this is something that is a little bit strange using this style of part. So you can see that there are 2 pin 1s, 2 pin 2s, and 2 pin 3s. So you're seeing both representations on the same table, and it might be a bit confusing, trying to figure out between, say, for example, pin 3, which one is which. Is the top one the default, or is the bottom one the default? So what I did here was I named one of the pins out instead of result, and yet you can see from the table now that it's the bottom one that corresponds to the DeMorgan representation. So once again, let's go ahead and go to the properties editor. Let's add a description, add a couple of keywords optionally. And as a side note, if you had a particular footprint that you wanted to associate with this part, that dialog is also where you would do it, but for now we're just sticking to symbols, and KiCad does permit you to make symbols that either do or don't have a footprint or a footprint associated with it. Okay, and we go back to the schematic just to see if it's there, and it is. We can place both symbols on the schematic, on the canvas. And just to give it a little test, personally, I like to flip it back and forth so you can highlight the part, right-click, and then look for DeMorgan, and that will let you easily toggle between both forms. Now, likewise, you can do the same with multi-unit parts. So, for example, you can switch unit A to unit B to unit C, and finally unit C to unit A. And again, this isn't really a requirement, it just speeds up the workflow. So now we have a multi-unit and a DeMorgan unit. Let's go back to the symbol editor. Once again, highlight the library, otherwise you'll get the error message that just popped up. Let's create a new symbol, and this third new symbol is going to be a symbol where we give it alternative pin names. So I'm naming it Baz, and pretty much I'm going to leave everything else as default. So let's move that reference out of the way, and let's create a few pins. Like usual, in the interest of time, I'm going to time-lapse ahead until the pins are all configured. Okay, and now we have our inputs, our outputs, and our two supplies. So one reason you might want to have a custom part with alternative pins is a lot of times with these microcontrollers and processors, you'll have default pin functions. So for example, on this microchip part, you've got PD2, port D3, port C1, but each of those also has an alternate function. So you've got, for example, a pin change interrupt, you've got a timer counter function, you've got a serial interface, and you can really put too much text on the screen if you try to encode all of that at once. So sometimes it's convenient to be able to just right-click your part and tell it which pin alternative you want to select. So the way you can do that here is go back into the symbol editor. You're going to select a specific pin by highlighting it, and at the bottom of the dialog you will see a alternative or alternate pin table. You want to click that to expand it, and then that is where you can hit the plus sign to write out your custom names for these alternative pin functions. Now, the other reason this is important is because depending on the standard you're using, whether it's ANSI or IEEE, different pins will have a different shape depending on what they're doing. So a default pin is just going to be a line, but a pin that is associated with a clock will have kind of like a triangle. A pin that's associated with a clock will have kind of a triangle or a bracket next to it. If a pin is, for example, inverted, it might have a circle next to it, and you can configure this inside the pin editor. So what I've done right now is I've gone back to the canvas, back to the schematic, and if I edit the part and I go to alternative pin layouts, I can go here to this column and I can get a drop down that has the alternative pin names, and this will automatically, once I select them, it will automatically adjust the pin shape as well. And we can also see that when you select these parts out of the symbol editor, or the symbol selector rather, you do get the default look. So what I personally recommend is, if you're trying to do this, pull up the manufacturer's data sheet and use that kind of like I did to identify what the default pin functions are and what the alternatives are, because the defaults are usually what you get when the device first powers up and before your code starts running. Alright, so we are going to add a fourth custom part now by first selecting the library and then going to add new part. And what this new part is going to be is essentially a power port. So for example, a ground symbol is a power port, a supply voltage rail is a power port. There's also a third type that I won't get into until a later video. But power ports operate quite a bit differently from other custom symbols, or any symbol for that matter. First of all, they don't appear on the schematic, or sorry, they don't appear on the bill of materials, they don't appear on the circuit board. They can only have one pin. The value can't be changed once you've created the part. I mean, you can go back into your library and change it that way, but you can't change it in the schematic. And when you wire something to a power port, the power port acts like a global label, and I'm not sure if I mentioned globals too often in this series so far, but that essentially means that if you have a multi-page sheet, your power port is going to be the same net on each page. So the main thing you want to do is just select power port when you go into that initial dialog creating your custom part, make sure it's checked, and when you go to draw your geometry and place your pins, you want to place one pin, give that pin number 1, make the pin name whatever net name you want to be assigned to any wire that you attach to it. And traditionally, you also want to, and this is where it gets a little bit tricky, I believe you want to make the reference value invisible. The reason you do that is if the reference value is visible on the schematic, for example, if I placed 3 grounds, by default you can't see this, but they're going to be named ground 01, ground 02, ground 03, and this is because KiCad doesn't like components that have the same name, or the same reference rather. So I tried to name this one 420 volts. It doesn't quite look the way I wanted it to, so I'm going to play around with some of the values here. You also want to place a pound sign in front of, I believe it's either the value or the reference. Sometimes I do forget which one it is because I don't create a whole lot of power pins. Yeah, normally I would trim this out of the video and I would just mention it in a quick statement. But I'm going to time-lapse over a little bit of this. And now you can see that when I drop it into the schematic, it looks a little bit more like you would expect. So it doesn't have duplicate text or things that are sideways. In my opinion, these take a little practice, and like I was suggesting, depending on whether you're based in the US or, say, for example, the EU, you might be required to draw your symbols in a certain way. So let's go ahead and test this power port out by trying to wire it to something. And you can see that once you've wired it to a component and you click the net or you click the wire, if you look in the bottom left corner of KiCad, you can see that the net name has changed to the pin name of that custom part. And again, it's the pin name that controls the name of the net. Now, the next type of part I'm going to make is effectively a derived part. What KiCad lets you do is if you create a library and you place a part inside that library, you can use that part as almost like a template to make additional parts. The default library does this a lot. The one downside to it is you can't change every possible property of the part, so I do recommend that if you, for example, if you have a need to make a large number of parts that are nearly identical, the derived part system could be good for you, but just give it a try first to make sure that you can change the values that you want to change. Otherwise, you're going to be stuck with a lot of components that essentially you're going to have to redo one way or another. It's meant to be kind of a labor-saving system, but it can, well, it does also reduce the file size, if I'm not mistaken, but it can take a little while to get used to. If you have an existing part in mind that is already on your system, another thing you can do is what I'm doing here. So I'm just picking a random component, a random power port, and what I'm going to do is I will pull it up in the symbol editor, and I'm going to pretty much just copy and paste it. So I believe that in KiCad either 5.0 or 6.0, so I believe that in KiCad 5.0 or 6.0, they changed the cut and paste system so that when you copy a part, it's actually the human readable code that describes the component. You can test this by pasting it into a text editor just to see what it looks like. So copying and pasting from library to library is a lot easier and a lot less awkward than it was in those older KiCad versions. I believe 6 was the first to do it, but I might be wrong about that. Okay, and you can see that this copy-pasted power port is now in the custom library. And really, if I had to make like a custom voltage rail or something, it gives you a good selection of defaults. But if I want to do an unusual voltage, like say 7.5 volts or something like that, I would probably do it by just copy-pasting one of the built-in power ports. And like I said, I don't really do this often, so it is pretty easy to forget whether you're supposed to like put that hashtag or the pound sign in front of the value or in front of the reference value. But anyway, I think you've got an idea of how it works now. The last note that I have on this is, depending on what company or agency you're working on, your components that have subunits, you might be required to, for example, instead of U1A, U1B, U1C, you might be required to put like a dash followed by a number, or maybe you have a dot between the base part and the subunit part, or the letter. So KiCad, of course, lets you do this as well. What you do is, in your schematic, just go to the top left, almost in the corner, and you'll see a settings icon. You want to click that, and you'll get an option to change the formatting for those subunits. If you plan on curating your own library of custom parts, there is kind of a, well, not kind of, there is a system for doing that, so it's called the KLC, KiCad Library Convention. It's on the website, and it gives you the guidelines, for example, for how to set the grid, how far apart the pins need to be, how to name things or not name things, what are considered illegal characters. And if you follow the guideline, and there are a couple of automated scripts to help speed this up, that's really your first step towards creating a really well-designed, well-curated library that is probably at a quality level that you could submit to some type of repository and let other people not only use it, but the point of standardizing it is to make it easy for people to identify what your part is, what properties it has. It's sort of like IUPAC naming convention in chemistry, where you see the name and you kind of immediately understand what you're getting. And that's pretty much it. You can find examples of how to do this also in the default library. There's, especially in the 7400 series, I think, very good layout in there. Anyway, I'd like to thank the people who encouraged me to continue this video series because, really, to be honest, last summer I completely lost the motivation to do it. It's not like I wasn't doing anything else. I had other projects going on, but, you know, when your tutorial series is getting 20 views in 30 days, I think that's what I said online, and that's not inaccurate, by the way. It is kind of a signal to try doing something else for a while, so that's why there's a 6-month gap. For this series, I originally planned and envisioned about 30 or 31 videos in the series, so the idea was, originally, if you're watching one video per day, you can learn pretty much the fundamentals of KiCad in a month. I can't really afford to do that, so I think at best the series is going to get sliced in half, so it'll be about 15 or 16 videos, and I'm probably going to stop somewhere in the board editor, like maybe doing trace layouts and stuff, but the advanced stuff like blind vias and differential pairs and all this stuff, I just have other projects going on, so I don't think that series is going to, or at least that part of the series is going to exist. But anyway, stick around. I believe there will be a part 10, so part 10 is going to cover, so that's going to involve multi-page schematics, hierarchy, and maybe a little bit about the text encoding if that video doesn't run long. If not, that would be the video after.